This is Advanced Math, Unit 6, Lesson 6. Solve equations and review. All right, solve for x such that 0 is less than or equal to x, which is less than 360 degrees. Okay, number 1, sine 2x plus cosine x equals 0. All right, when you try to solve this, you can see first off there's no like terms. There's no GCF, there's not really anything I can do. So think of all your identities and laws that you have, double angles, angle addition, and recognize that sine 2x is something you can change. I can't change cosine x because cosine x is just cosine x. But if you remember sine 2x or sine 2 theta, we learned the other day is 2 sine theta cosine theta. So this is going to be 2 sine x cosine x. Again, sine 2x is 2 sine x cosine x plus cosine x equals 0. Now that I've changed the sine 2x to this, now I have a GCF that I can pull out. Cosine x times 2 sine x plus 1 equals 0. Okay, so taking a look at that one there, what can we do? Zero product property allows me to do cosine of x equals 0 and 2 sine x plus 1 equals 0. When I solve this, I get sine of x equals negative 1/2. There's two places where cosine 0, that's 90 and 270. And there's two places where sine is negative 1/2, that's 210 and 330. All right, number 2. 1 minus 3 cosine x minus cosine 2x equals 0. Now this particular type of problem is on the test, and it's one that kids struggle with because cosine 2x has multiple possibilities. We have 3 choices. Where sine of 2x, there's only one choice, 2 sine x cosine x, that's it. But cosine 2x, if you remember from the previous lesson, has 3 different possibilities that we can use here. And how do we know which one to use? Technically, it doesn't matter. It's going to be one that's easier, that's going to go a little quicker. So if you take a look, cover that, and all I have there is cosine. 1 minus 3 cosine. There's no sine at all. So if I were to pick one, I would pick this one. Why throw a sine squared in there if there's no sine in there to be a like term or a GCF? So the one I'm going to pick is this one right here. Why? Because it's the only one that has only cosine in it. So 1 minus 3 cosine x is going to stay, minus, and then I have here cosine 2x. I said I was going to use 2 cosine squared x minus 1. Recognizing though that because that's a minus, I do have to put parentheses here to distribute that negative. Equals 0. 1 minus 3 cosine x minus 2 cosine squared x plus 1 equals 0. All right, combine like terms and put in order. I'm going to put the negative 2 cosine squared x out front, and then the minus 3 cosine x in the middle, and then 1 and 1 is plus 2 equals 0. Divide both sides by the negative 1 or move everything over to the other side. Positive 2 cosine squared x plus 3 cosine x minus 2 equals 0. And then up to you on how you factor it. Factor as it is or use substitution. 2u squared plus 3u minus 2. So we're letting, I'll put it, squeeze it right in here, u equals cosine of x. Again, you don't have to. If you can factor as is, go for it. Double bubble equals 0. 2u and u to get the 2u squared. 2 and 1, I don't want to put the 2 and the 2 together. And you just have to figure out which one's positive, which one's negative. So let's see, if this is negative and that's positive, that gives me negative 1, positive 4, which gives me the positive 3. All right, u equals 1/2, u equals negative 2, but u is cosine of x, so cosine x equals positive 1/2, cosine of x equals negative 2. Remembering from our last unit, if you put this as negative 2 over 1, that means your adjacent side is 2 and your hypotenuse is 1, which makes no kind of sense. So this one here has no solution. This part does have a solution, so you don't have to write no solution as part of your answer. That's just for this piece. But this one, cosine x equals 1/2 at 60 degrees and at 300 degrees. Okay, number 3. Sine squared x minus cosine 2x equals 5/4. All right, I can see right now there's no way to factor, there's no like terms. I'm going to pause right here and jump back to this one. I'm recognizing, and I should have clarified it earlier, these two are not like terms. This one has a 2x, the cosine x does not. They are not like terms. You cannot add them and get like a cosine 3x or cosine squared, anything. They're not like terms. Okay, back to this one. They're definitely not like terms and no GCF. So if there's something I'm going to change, it's going to be this one because I have my double angle identities that I can use. I could change sine squared using Pythagorean's identities, but I don't want to have to do that because this is the newest thing we've learned. I'm going to use that. Remembering cosine 2x has 3 possibilities. How do we know which one to use? Let's see. There's already a sine squared, and if I change this, all I'm going to have is a sine squared. So which one do I want to use? I would say this one. Why throw any cosines or cosine squareds in there if I don't have to? So I'm going to use the middle one. So sine squared is going to stay sine squared. Minus, and then cosine 2x, I said I was going to use 1 minus 2 sine squared x. And remembering that minus sign will have to be distributed, equals 5/4. All right, sine squared x minus 1 plus 2 sine squared x equals 5/4. Okay, I do have like terms right here. 1 sine squared and 2 sine squared is 3 sine squared x. Minus 1 equals 5/4. I'm going to add the 1 to the other side, and 1 is the same as 4/4. And I'm only doing that so there can be a common denominator. 3 sine squared x equals 5/4 plus 4/4 is 9/4. And then we square root both sides. And some people did forget this on the test. Oh, I jumped the gun and should not have square rooted both sides yet. I don't want to do it yet, and I'm hoping you can figure out why I did it too quickly. I still have the coefficient of 3 in the front, and so I cannot square root just yet, unless I want to end up with the radical 3, which I do not want to end up with. All right, so I apologize. I'm going to fix it. So before square rooting both sides, I'm going to divide by 3, remembering that dividing by 3 is equivalent to multiplying by 1/3. And I'm only going to do that since there's a fraction already on the other side. The 3's cross out. Sine squared x equals, when I cross reduce, that's 1, that's 3, that gives me 3/4. And now I'm ready to square root both sides. Square root, sine of x equals plus or minus root 3 over 2. Sine of x equals plus or minus root 3 over 2. Reference angle here is 60 degrees. In all 4 quadrants, because it's plus or minus, that would be 60, 120, 240, and 300. All right, number 4. Sine 2x cosine x plus sine 2x equals 0. Now, as tempting as it is to change your sine 2x and your sine 2x, it is tempting to do that. Recognize first that there's a GCF. Your sine 2x can be factored out. Sine 2x parentheses 2 cosine x plus 1 equals 0. Sine 2x equals 0. We're using the zero product property. And when I set this equal to 0, I'm going to solve it all in one step. When I set that equal to 0, I would subtract 1, divide by 2. Cosine x equals negative 1/2. All right, we'll do this one first because it's a little easier. Cosine x equals negative 1/2 at 120 and 240. The reference angle is 60 degrees. 60 degrees in quadrant 3 and 4. No, I'm sorry, 2 and 3. Sine 2x equals 0. You have choices. You can expand your sine 2x to 2 sine x cosine x. You can do that. Or do the whole twice around business. I'm just going to do the twice around to give us that review because we're going to need it again for the final anyway. So sine of what angle is 0? Sine is 0 at 0 degrees and 180 degrees. And then we add 360 to each one. We add 360 to each one to go twice around. This is the first set. This is going to be the second set. 0 plus 360 is 360. 180 plus 360 is 540. And then we divide everything by 2, including the original set of numbers, the 0 and 180. Divide them all by 2. X equals 0, 90, 180, 270, and then the other 2 answers we had earlier, the 120 and the 240. If you don't like this way, technically you could change the sine 2x to, what is it, 2 sine x cosine x equals 0. Divide both sides by 2. So sine x cosine x still equals 0. And then use the zero product property. Sine x equals 0, 0, 180. I'm sorry, at 0, and sine x equals 0 at 0 and 180. And then cosine x equals 0 at 90, 270. So you'd still get the same set of numbers, same answers. All right, that is it for number 4. I'm going to flip the page and do some quick test review. We still have other stuff we have to get through, but I just want to quickly do just some review problems because these are ones that I've recognized over the years that kids tend to mess up on. Simplify. Number 1, sine of theta plus 40 degrees cosine of 20 degrees minus theta plus sine of 20 degrees minus theta and cosine of theta plus 40 degrees. Okay. Test question that's often missed because students approach it incorrectly. They see this as angle addition. Oh, sine of A plus B, expand. Cosine of A minus B, expand. And then you're going to have to double distribute that. And then they expand, and same thing, you're going to have to double distribute. It ends up getting really, really messy. Rarely do kids get it right when they do it that way. It's possible, but it takes like line upon line upon line upon line. Do not do that to yourself. Recognize, as tempting as it is to expand each one, that I have a sine with a cosine, theta plus 40, theta plus 40, 20 minus theta, and 20 minus theta. Recognize that it's already been expanded. It's friendly, so it's the sine formula. And remember, sine is always with your, or A is always with your first sign, so that is A and that is B. Sine of A minus B or plus B. It's going to be plus because of that plus sign right there. Sine of A being theta plus 40, plus B, where B is 20 minus theta. So I have sine of theta plus 40, no negative to distribute, so plus 20 minus theta. Sorry, that's a theta. My thetas end up crossing out, theta, negative theta, leaving me with sine of 60. Being careful, everyone that we've done in the past, I've always said, leave it as it is because you can't evaluate, but 60 is a special angle. If it ever ends up being a special angle, 60 or 30 or 45 or any of those in any quadrant, or 90 or 70, any special angle from our unit circle, evaluate it. Sine of 60 is root 3 over 2. So root 3 over 2 is your final answer. On the test, make sure you remember to go over this and recognize this on the test. Don't let this be the one to get you to miss points on the test because you didn't remember to condense it to a single sine function. Okay, next one. Number 2, cosine of 70, sine of 25, minus sine of 70, cosine of 25. Okay, recognizing that it's already been expanded, I'm going to condense. Sine is with cosine, so it's the friendly one, it's sine. A plus B or A minus B, sine keeps the sign, so it's minus. Now remembering, if it's minus, subtraction is not commutative. It is important to know which one is A, which one is B, because if you flip-flop them, you're going to end up with the wrong answer. Okay, now I've said it before and hoping you remember, A is always with your first sign. A is always with your first sign, so that means this is A and this is B. The biggest mistake kids make is they just get so used to them saying, oh, A is the first one, B is the second one, so they'll do sine of 70 minus 25. And it's really 25 minus 70. You'd get it wrong the other way because you'd end up with the negative. And sine does not absorb the negative. So, one more time, don't get so caught up in going as fast as you can and say, oh, that's A, that's B, and go on. Recognize that this is out of order. And it doesn't matter because multiplication is commutative, but A is still always with your first sign, not your second sign, your first sign. So sine of 25 minus 70. So that is sine of negative 45 How you do it is up to you. Sine of negative 45, negative 45's in quadrant 4. And so that is going to be negative 1 over root 2. Or you can think of it as kicking it to the front. Negative sine of 45. Sine of positive 45 is 1 over root 2. Opposite of that is still negative 1 over root 2. So it's up to you and how you think of it. Negative 45 is in quadrant 4. Therefore, sine is negative 1 over root 2. Or kick it to the front. The opposite of sine of positive 45. Again, how you do it is up to you. All right, number 3. 1 over cosine 40, cosine 15, they're both degrees, minus sine of 40 degrees and sine of 15 degrees. Okay, so taking a look at that, and first off, what is that? We've never seen anything like it. But recognizing that if you ignore that it's a fraction, if you just look at that bottom piece, does that bottom piece look familiar? Cosine with cosine, sine with sine. Again, that's cosine with cosine, sine with sine. So that is your angle addition for cosine. Now, it's in the bottom of a fraction. So let's just clean it up the same way we usually would. 1 over, we said it's cosine because it's snobby. And opposite, so it's addition. If it's addition, it doesn't matter which one's A or B. And with cosine, it doesn't matter which one's A or B even when you subtract. Because remember, cosine absorbs the negative. So you have cosine of 40 plus 15, which equals 1 over cosine of 55 degrees. And we talked last unit, don't leave your answer like this. What's 1 over cosine? Secant. So you have secant of 55 degrees as your final answer. Okay, so we've never really seen one like this, but we know how to simplify the denominator. And once we simplify, we can recognize, hey, that secant of 55 degrees is your final answer. And that is it for this lesson.